continuing our rational transformation, and so so go back and look at video 1 if you're just joining me. There on this one, they've given me a function f and a function g, and they ask for the domain and range. Okay, f, domain and range is going to be all real, and g, we can do anything we want except we can't plug in 3. So the domain here, domain would be from negative infinity to positive 3. Pick it up again from 3 to infinity. That's an infinity sign, believe it or not. As far as the range, we would need to look at our calculator. So what's going to happen here is the first one, f of x, has a y-intercept there of negative 5, 1, 2, 3, 4, 5, and then it has a slope of 2, so we go up 2 over 1, up 2 over 1, up 2 over 1, and we're doing something like that. And the reason I'm making it dotted is because the other graph is going to have a y-intercept. What was this? So this is 2, so 3 is going to be somewhere in here. Do you see what I mean? This had an x value. This point right here had an x value of 2, so somewhere. And then this would be, that should be through here. Okay, pretend I did that correctly. I'm so sorry. This is an asymptote of x equals 3. So if I'm trying to graph this one right here, it's gonna use this asymptote. Let's see if you can see it. It's going to use this these two dotted lines as our asymptotes. So the question I want to know is, does it kind of follow this shape through here? Does it and then here, or does it do this sort of thing and then that? So the easiest way without a calculator is to plug in a number. And so, like if I say g of 0, g of 0 would give me 2. So negative 3. Plus, minus a third. Okay, so that's somewhere negative. Negative 3, so 1, 2, 3, 4. Well, this was negative 5, so it's negative 3 and something. So it's down in here somewhere. So that tells me that it's going to do, pretend I can draw, something like that and something like this. So if it's following those, it's a lot easier to see the range will be all reals. If it's in here, and here, then we'd have to find the maximum at this point and the minimum here. Maybe we'll do an example like that. At this point, I would give you a calculator to find that because you don't know the calculus to find the max and min. If you do know the calculus, then you can do it by hand. Okay, so I've sketched those graphs. Describe what I see. Well, what I saw was that f of x was an asymptote for g of x. And then what they want us to do is they want us to take g of x, which is 2x minus 5 plus 1 over x minus 3, and basically get a common denominator. So I'm going to come here and say, okay, well, 2x minus 5 all needs this denominator of x minus 3. Okay, so, well, I might not write this step for myself, but I'll write it for you. Okay, so now I'm going to FOIL. 2x squared, and then this is negative 5 and a negative 6, so negative 11x. That's positive 15, plus 1. And so this becomes 2x squared minus 11x plus 16 over x minus 3. And that's why, and this was our g of x. That's why we can take an equation like this. We recognize that it was top-heavy, so we knew in the past we would say, oh, well, that has a slant asymptote. It might be slant, it might be something else, but in this case, since that degree is 1 bigger, the slant asymptote is actually, it is a slant, it's actually a line. And so we could have gone from here, we could divide to figure out what that line is that we're using as an asymptote. This next one does something similar, except this is now a quadratic. It's going to have a quadratic asymptote as opposed to a linear asymptote. So my answer key has all the details, but I'm going to just jump to part D so you can see what's happening. If I have this, it's going to be this x squared minus 6x plus 11 that needs to get that common denominator of x minus 2. Okay, all right, off to the side. Let's just do x minus 2 is multiplying through by x squared minus 6x plus 11. So that gives me x cubed minus 6x squared plus 11x. Then do the negative 2. Negative 2x squared, positive 12x, negative 22. I've done this on purpose where I lined it up so I get all my like terms. Make sure my arithmetic is correct. So this part right here became that. Oh, and now I have to add plus 1. Can you handle all that in one time? Well, here I go. It becomes x cubed minus 8x squared plus 23x. It had been minus 21 plus 1, so minus 20. I said 21. My brain sometimes gives me the answer. That's minus 22 plus 1 is a negative 21. So sorry. And that's all over this denominator. So if you had started here, then you would see it's top heavy, but it's top heavy when I divide, I have a cubic divided by linear, I get a quadratic. And so this quadratic up here is going to become one of your asymptotes. By the way, the other asymptote would be x equals 2, would be an asymptote. Okay, I would encourage you to go find my answer key to this because I'm sure I have it posted and figure out, fill in the missing parts that I didn't feel like talking about. Enjoy!